Alright, on number 1, when you think of the square root of 0.49, I would think of it as the square root of, take the whole number, 49, and divide it by tens, hundredths, or 2 decimal places, so 2 zeros, so 100. And then you can split it up as the square root of 49 over the square root of 100, and the square root of 49 is 7, and the square root of 100 is 10. And 7/10, since the problem started in decimal form, we want to end it in decimal form, so 0.7 is the answer for that one. On the next one, I've got the cubed root of 0.125. So I put the cubed root of, the whole number is 125, and then tens, hundredths, thousandths. So I put 1,000 below, or 3 zeros, if you think about it like that. And then if you look at your power chart, you notice that 125 is 5 cubed. So 125 is 5 cubed, which means the cubed root of 125 is 5. And the cubed root of 1,000 is 10, since 10 cubed is 1,000. So that is 10. And 5/10, you can simplify it down to 1/2, but that is as a decimal 0.5. Okay? On the next one, I've got the fourth root of 0.0016. So I've got the whole number 16, and tens, hundredths, thousandths, 10,000, so 10,000. And I'm taking the fourth root, and so I notice that 16 is 2 to the fourth, so the fourth root of 16 is 2, and the fourth root of 10,000 is 10. So I've got 0.2 as my answer. And then on number 4, I've got the fourth root of 6,561 over 625. So I'm going to try and find those on my power chart, and I noticed that 9 to the fourth is 6,561, and the fourth root of 625 is 5. So 5 to the fourth and 9 to the fourth, so that is 9 over 5, and that is all I can do. And since I started with a fraction, I don't have to make it a decimal. And so there we go. So, moving on to 5 through 8. For the first one, I think about the square root of 72. 72 is not a perfect square, but 36 is, and 36 goes into it twice. So, I'm going to go ahead and take the square root of that. So I've got the square root of 36, which is 6, and then I leave the 2 on the interior. And then I'm going to work with each variable. So I know that this is an understood 2 right here. So I ask myself, how many times is 2 going to 2? And that's once. You don't need that power button, but I go ahead and write it. How many times is 2 going to 5? And that is twice, with 1 left over. And z, I've got how many times is 2 going to 3? And that is once, with 1 left over. And again, you don't need the power one. Now, be careful about your 2's and your z's, because they start to look a lot alike, which is why I put the line through the z. Okay. On number 6, I've got the cubed root of 32. So it might be easiest to go ahead and just look at your power chart and see that 2 to the 5th is 32. So since 2 to the 5th is 32, I'm going to rewrite that as 2 to the 5th. So in all of these, I'm going to think of them as how many times does the root go into the power. So 3 goes into 5 one time, with 2 left over, and 2 squared is 4. So I'll end up putting a 4 in my final answer. 3 goes into 12 4 times. I'll do it with a different color. 3 goes into 12 4 times, with none left over. Three does not go into 2 at all, so I leave y squared in the interior. And 3 goes into 9 3 times evenly with none left over. So my final answer is going to be to x to the fourth z cubed times the cubed root of 4y squared. So on the next one, I've got the 4th root of 324, x to the 13th, y to the 6th, z to the 18th. I need to find a perfect fourth power. Now, if you look on the fourth power, you don't see 324, but 324, I think, does it divide by 16? Does it divide by 81? I know it doesn't divide by 256, so those are my only real options. And if I think about 81 times by 4, 8 times 4 is 32, and 1 times 4 is 4. So, sorry, I wasn't even showing you. My fourth power, so I got 16, 81, 256 is too big to divide into 324. So, I'm thinking this is 81 times 4. And I know that the fourth root of 81 is 3. So, I'm going to have a 3 on the exterior. And we'll see what's left on the interior. So when I go to x's, how many times is 4 going to 13? 4 times 3, so 3 times is 12. So that has one, oh, I got a 4. I forgot my 4. So that was that, and then that stays inside. Okay, so now we go to this. 4 goes into 13 3 times with 1 left over. 4 goes into 6. 4 goes into 6 one time with 2 left over. And 4 goes into 18. 4 times 4 is 16, and that leaves me with 2 left over. And there's my answer. Okay. On number 8. I've got the 6th root of 1458. So 1458, if I look at powers of 6, we got 64, 729, 4096, and 15,000. So this is only 1,000, so those are too big. So the only options I have are 64 and 729. I know that 7 times 2 is 14, and 29 times 2 is 58. So that is just 729 times 2. And I know that the 6th root of 729 is 3. So I've got a 3 on the exterior and a 2 on the interior. And then I start working on it. So W's. How many times does 6 go into 40? Well, 6 times 6 is 36. So I'd say 6 times with 4 left over, because 36. You should always be able to multiply this times this and add that to get the original. 6 times 6 is 36 plus 4 is 40. Okay? 6 goes into 18 3 times evenly, so none left over. 6 goes into 11 one time with 5 left over. And 6 goes into 27. 6 times 4 is 24, so 4 times with 24, so 3 left over. And there's my answer on that one. Is that too fast for y'all to be able to follow? You can't hear me, can you? Yeah. Do you want me to try and talk louder? Okay. Y'all can keep talking, but I'm going to talk louder so they can hear me if they want to, up there. Whoever's watching. So when I multiply number 9, I've got 6 times this square root and 2 times this square root. Technically, I could probably just go ahead and take the square roots of both, but I'm going to go ahead and multiply 6 times 2 and get 12 times the square root of 4 times 9. Now, you could just write 4 and 9 and take the square root of them individually, but I know 4 times 9 is also a perfect square, so I'll go ahead and say 36. And then x squared times x squared is x to the fourth, and then y squared. And now I'm going to square root. So I've got 12 times the square root of 36 is 6. How many times is 2 going to 4? That is twice. And how many times is 2 going to 2? And that is once. So I end up with just 6 times 12 is 72. 72 x squared y. On number 10, I've got a number in the front on this one and not on that one, so I'll just put a 3 in the front times the fourth root of, and then I'm just going to combine all these things. I'm not actually going to multiply 16 and 625. I'm just going to write 16 times 625. But I'm going to combine my x's. X to the 11th and x to the 5th. That's x to the 16th. And then y to the 7th and y to the 11th is y to the 18th. So now I need to take the fourth root. So I noticed that when I'm looking for fourth roots, I'm looking at powers of 4. And 2 to the fourth is 16. And 5 to the fourth is 625. So the fourth root of 16 is 2, and the fourth root of 625 is 5. So that means I have a 3 on the exterior. I now have a 2 because the fourth root of 16 is 2, and a 5 because the fourth root of 625 is 5. And then I got to deal with the variables. 4 goes into 16 4 times evenly, and 4 goes into 18 4 times as well, but that's 16, so that leaves me with 2 left over. So I basically just took the fourth root of that, that's 2. The fourth root of that is 5. The fourth root of x is 16th is x to the fourth. 4 goes into 18 4 times with 1 left over, so then I combine. That's 6 times 5, that's 30. X to the fourth, y to the fourth, times the fourth root of y squared. On number 11, I'm going to do the same thing, although, yeah, no, I got. So I've got negative 2 times the cubed root of 20 times 500. I've got x to the 9th and x to the 4th, that's x to the 13th. Y to the 14th and y to the 12th, that's y to the 26th. Z to the 4th and z to the 8th, that is z to the 12th. So when I'm trying to find the cubed root of this number in the front, I'm going to break it down into, I say prime factors, but if I notice something, I'm going to go ahead and use it. I know 20 is 2 times 10, and I know 50 is, or 500 is 5 times 100, which I notice is 2 times 5 is 10, times another 10, times 100, which is 10 squared, which makes that 10 to the 4th. Now, if you wrote it as just 10,000, if you figured out that 2 times 500 is 1,000, so add another 0, it's 10,000. Then you could have just said, oh, well, 10,000 is 10 to the 4th. Either way, if I take the cubed root of 10 to the 4th, 3 goes into 4 one time with 1 left over. So I'm going to have a 10 on the outside and a 10 on the inside. But I already have a negative 2 on the outside, so that means I'm going to have a negative 20 on the outside and a 10 left on the inside. Now, if you broke it down into its very prime factors, you could say, well, let me see. 20 times 500. 20 times 500. If you broke it down all the way, then you would be like 2 times 10, which is 2 times 2 times 5. 500 is 5 times 100, or 5 times Well, you could say a lot of different ways, but if you want to go ahead and say 10 times 10, then that is 2 times 5 times 2 times 5 times 5 times 5 times 2 times 2. So 2, 2, 5, 5, 2 and 5, 2 and 5. So I notice that's 1, 2, 3, 4, 2 to the fourth, and 1, 2, 3, 4, 5 to the fourth. So if I were taking the cubed root of that, 3 goes into 4 one time with 1 left over. 3 goes into 4 one time with 1 left over. And so you see how it's 10 and 10. That's just another way to break it down. Okay, now I deal with the variables. 3 goes into 13 4 times. 3 times 4 is 12. That leaves me with 1 left over. 3 goes into 26 8 times, because 3 times 4 is 24, and that leaves me with 2 left over. And 3 goes into 12 4 times evenly, and that is my answer. Okay, on the next one it says divide, simplify, and rationalize. So they're both underneath the square root, which means I can divide them. 18 and 10 both divide by 2, so I'm going to go ahead and write 9 and 5. So I've got the square root of 9 over the square root of 5. The square root of 9 is 3, and the square root of 5 is just square root of 5, but it does say to rationalize. So I need to multiply top and bottom by the square root in the denominator, which leaves me with 3 square roots of 5 over 5. On number 13, I'm going to go ahead and divide and simplify like I did on the last one. 9 and 18 both divide by 9, leave me with 2 in the denominator. I can cancel out 4 of those with 4 of those, leave me with 2 in the numerator. So I've got the square root of x squared in the numerator and the square root of 2 in the denominator. So I can simplify the square root of x squared. 2 goes into 2 one time, so that's just x over the square root of 2. But I need to rationalize. Yes?
I need Kelsey Boogie to come check out, please.
Okay.
Thank you.
That was very intense. I need you to do this now, Kelsey. Go now. Okay, so then I need to rationalize, so I multiply by square root of 2 on top and bottom, which makes this just, now you can say the square root of 2x, or the x squared to 2, doesn't really matter. It is the coefficient, so I'm going to put it in the front over just 2, because that is just 2. Square root of 2 times square root of 2. Not undone? I know what you're saying. Okay. Now on number 14. Guys, if you were not here for for the dividing, then you might want to pay attention, especially my sophomores. I'm going to write this a little bit bigger. So I've got the cubed root of negative 64 x to the 7th over 8x to the 6th, y to the 7th, z to the 3rd. Okay. Oh, so you can hear? Okay. So the first thing I'm going to do is simplify the 64 and the 8. So 64 and 8 both divide by 8, so that goes away, and then that's just negative 8 in the numerator. The x's, 6 of those can cancel out with 6 of those, leaving me with just 1 of them. 4 of those can cancel out with 4 of those, leaving me with 3. And 3 of those cancel out with 3 of those, leaving me with just 3. So the expression that I have right now is the cubed root of negative 8 x to the first z to the 3rd over the cubed root of y to the third. Now this one's actually really nice because almost everything works out. The cubed root of negative 8, the cubed root of a negative is a negative, so it is negative, and the cubed root of 8 is 2. X cannot come out of the cubed root because it only has a power of 1. But 3 goes into 3 one time, so z can come out. And then when we divide, 3 goes into 3 one time, which leaves me with just y. There's nothing to rationalize because there's no roots on the bottom, so that is my answer. So I'm going to simplify whatever I can vertically with the variables and with the coefficients. And then I'm going to start simplifying. And then if there's any root left in the denominator, then I'll rationalize. So let me write down the next one. I've got the cubed root of 32 x to the 5th, y to the 9th, z to the 8th, over the cubed root of 10x to the 7th, y to the 7th, z to the 15th. Okay, so the first thing I want to do is simplify 32 and 10. They both divide by 2. So I'm left with 16 and 5. I want to simplify the x's. I can cancel out 5 of them with 5 of these, leaving me with 2 in the denominator. I'm going to cancel out 7 of those or simplify with 7 of those, leaving me with 2 in the numerator. And I'm going to simplify 8 of those with 8 of these, leaving me with 7 in the denominator. So what I've got right now is the cubed root of 16 y squared over the cubed root of 5 x squared z to the 7th. So before I move on and start rationalizing, I need to see if there's any perfect cubes that I can simplify out. And I know that 16 is 2 to the 4th, or you can think of it as 8 times 2. So when I think about the cubed root of 2 to the 4th, 3 goes into 4 one time with 1 left over. So I'm going to 2 on the outside and 2 on the inside. And 3 does not go into 2, so I have to leave that in. So I've got 2 on the outside, 2 on the inside, and then y squared left on the inside. Divided by, I can't take the cubed root of 5. 3 doesn't go into 2, but 3 does go into 7 twice. So 2 times with 1 left over, because it's 3 times 2 is 6. So 1 left over to make 7. So I've got 5x squared and then z. So I need to rationalize. When you rationalize, you got to make sure that you get rid of the root in the denominator. If it's a square root, I multiply it by itself 1 time. If it's a cubed root, I've got to multiply by 2 more so that I have the cubed root cubed. So it actually takes 2 more of these. Okay? And the reason why we do that is because if I take the cubed root of 5x squared z and I cube it by multiplying it by itself 3 times, those cancel each other out. I'm just left with 5x squared z, meaning I no longer have a cubed root. So this is 5x squared z, but I'm multiplying it times another z squared. So that means my denominator is 5x squared z cubed. So I got 5x squared z times z squared. Okay. I'm actually going to write that down here. Alright, now let's start simplifying the numerator. So in my numerator, I have this 2 in the front. I have the cubed root of, I have a 2 and then 2 5, so that is 2 and 5 squared. I have x squared and x squared, that is x to the 4th. I have a y squared. And I have 2 z's, which makes that z squared. So at this point, what I have to do is simplify anything that I can in the numerator. And I cannot take the cubed root of 2 It's just 2 to the first power, and I can't say 3 doesn't go into 2. So none of this can be simplified with a cubed root, which means it's 2 times 25, and that is 50. So I'll just go ahead and leave a 50 in the interior. Okay, I have my 2 out in the front. Now, as far as the x and the y and the z go, if I look at the x's, I have x to the 4th. 3 goes into 4 one time with 1 left over. 3 does not go into 2, so I just have to leave y squared in there. And 3 does not go into the 2. 3 does not go into 2, so I just have to leave z squared in there as well. So there's only one other thing I can do, and that is simplify with the expressions out in the front. And I notice I have an x in the front and an x in the denominator. So my final answer is 2 times the cubed root of 50x y squared z squared over 5xz cubed. I have another one similar to that later, so we will get to practice that again. Although, yeah, we'll do it. Okay. Alright, so let's go to 16. Okay, on number 16, it says simplify and rationalize all denominators. I don't have a denominator, so I don't worry about that, but I do need to simplify. So I know that the square root of 8 can be simplified, because you're always trying to find the perfect squares that go into it. And I know that 8 is 4 times 2. I know that if I've got a 10 out in the front, that means 10 times, and the square root of 4 is 2 root 2. So the square root of 4 is 2. We'll leave that 2 in the interior, which makes that 20 root 2. 300 is 100 times 3, so I'm trying to find the perfect squares. So the square root of 100 is 10, so I've got minus 3 times 10 root 3. Square root of 100 is 10, 3 stays inside, so that's minus 30 root 3. And 50 is 25 times 2. So the square root of 25 is 5, so I've got minus 8 times 5, and then leave the square root of 2, so minus 40 root 2. And at that point, all I can do is combine if they have a similar radicand, the same radicand. I have 2 square roots of 2, so I have 20 of them minus 40 of them. That's negative 20 square roots of 2 minus 30 square roots of 3. So when you have an expression like this, and you will, just simplify the perfect squares out, combine them with the coefficients in front if possible, and then combine whichever ones have the same radicand. Okay? So on 17, when you're dividing two irrational expressions, or an expression by an irrational expression, you have to multiply to get rid of the radical. And you always want to multiply by the conjugate of the denominator. It happens to be the numerator as well, but we're going to multiply by the conjugate of the denominator. So I'm going to multiply by 4 plus the square root of 6 on both numerator and denominator. You cannot multiply by different things. That's the only way this works, is that they're the exact same thing. So then I start multiplying. Four times 4 is 16. Now, if you know the shortcut when multiplying conjugates, you don't have to worry about working it all out. I'm going to go ahead and do that, though. 4 times the square root of 6 is 4 square roots of 6. Negative square root of 6 times 4 is just negative 4 square roots of 6. And negative square root of 6 times positive square root of 6 is just negative 6. You can think of it as negative square root of 36, but that is just negative 6. which means my denominator simplifies down to 10 because the middle terms will cancel out and 16 minus 6 is 10. In the numerator, I've got 4 times 4, which is 16, very similar to the one below it. 4 times the square root of 6 is 4 square roots of 6. Square root of 6 times 4 is 4 square roots of 6. And the square root of 6 times the square root of 6 is just positive 6. So I've got 16 plus 6, which is 22. And I've got 4 square roots of 6 plus 4 square roots of 6, that is 8 square roots of 6. Now, as far as this expression goes, the numbers 22, 8, and 10 all divide by, you want to get the review chart there. And then, did you miss 3.5? Okay, so it's right there. So 22, 8, and 10 are all even, so I can divide them by 2. So I'm going to write 11, 4, and 5. So my final answer is 11 plus 4 square roots of 6 over 5. You should always simplify if you can. Okay. Number 18. Again, I need to multiply by the conjugate of the denominator. So, let's go ahead and do that. To make it no longer have an irrational number in the denominator, I've got 5 minus 3 square roots of 5 in both the numerator and denominator. Okay. So when I start this out, I get 25. 5 times a negative 3 square roots of 5 is a negative 15 square roots of 5. You just multiply the numbers in the front and tack on the square root. 3 square roots of 5 times 5 is just 15 square roots of 5. And then 3 square roots of 5 times negative 3 square roots of 5. So 3 square roots of 5 times a negative 3 square roots of 5 is a negative 9 times 5. Because the square root of 5 times square root of 5 is 5. 3 times negative 3 is negative 9, so that is a negative 45. So I've got minus 45 at the bottom, or at the end. Okay, then my numerator, I'm going to start multiplying. I've got 2 times 5, which is 10. 2 times negative 3 square roots of 5 is a negative 6 square roots of 5. Square root of 5 times 5 is a positive 5 square roots of 5. And a positive square root of 5 times a negative 3 square roots of 5. A positive square root of 5 times a negative 3 square roots of 5 is just a negative 3 times 5, which is a negative 15. So when I multiply those two, I just get negative 15. So I'm going to rewrite the numerator and denominator. 10 minus 15 is negative 5. So my numerator is negative 5, and then negative 6 square roots of 5 plus 5 square roots of 5 is negative 1 square roots of 5, or just negative square root of 5. And my denominator, the middle two terms cancel out. And I'm just up to 25 minus 45, that is negative 20. But what we can't have is a negative in the denominator. So basically just divide every term by a negative. And I'm left with 5 plus the square root of 5 divided by 20. Now, I do agree that that's a 5 and that's a 5 and that's a 20. But that's a 5 inside a square root. So since I can't simplify them all, I'm not going to simplify any of them. If you wanted to, you could say 1/4 plus the square root of 5 over 20. But it's no simpler, so I wouldn't necessarily do it. I would just stop right there. Okay. On number 19, similar to the previous one, I've got to simplify the perfect squares out. So for 48, 48, a lot of people like to think 4 and 12 or 6 and 8, but if you want to do 16 and 3, you want to find the largest perfect square. If you actually just broke it down, whatever you think, 48, if you say 4 and 12, well, to me that's 2 squared times 4 times 3, that's 12, which is 2 squared times 3. So I've got 2 squared times 2 squared, that's 2 to the 4th times 3. So if you're taking the square root of that and you ask yourself how many times does 2 go into 4, that is twice, with none left over, and then you're left with the 3. So that is the 4 square roots of 3. Same thing if you just think of it as 16 times 3. So just another way of looking at it. Okay, so the square root of 16 is 4, so I've got 4 square roots of 3. 27, I'm thinking square root, so I've got to look at perfect squares. That's 9 times 3. If it was cubed root, I would just say the cubed root of 27 is 3. I've got a negative 3 in the front, so when I take this is 3 square roots of 3. But then I've got another negative 3 in the front, so that's negative 9 square roots of 3. And for this last one, 75 is 25 times 3. And that is 5 square roots of 3, so I've already got 2 in the front. That makes that 10 square roots of 3. So as far as combining, I just need to, they all have square root of 3, so I can combine them all. 10 minus 9 is 1, plus 4 is 5, so I've got 5 square roots of 3. Okay, on 20, we're just multiplying, 20 and 21. So let's just start distributing. I've got 3 times 1, which is 3. 3 times 6 square roots of 5 is 18 square roots of 5. Square root of 3 times 1 is just square root of 3. And square root of 3 times 6 square roots of 5 is 6 square roots of 15. So they don't have the same square root, so the only thing I can do is multiply the numbers inside. The 3 and the 3 and the 5. As far as simplifying goes, there's nothing I can do. So I'm done. Don't think that you're wrong just because something doesn't simplify, because it doesn't necessarily have to. I don't know if any of y'all worked that problem and were like, maybe not. Okay. Okay, so let's do the next one. I've got negative 7 times 4, which is negative 28. I've got negative 7 times negative 2 square roots of 3. That is a positive 14 square roots of 3. I've got 5 square roots of 3 times 4. So that's 5 times 4. That's 20 square roots of 3. And then this last one, I've got 5 square roots of 3 times negative 2 square roots of 3. So if you need to, write it out. 5 square roots of 3 times negative 2 square roots of 3. That is negative 10 times 3. So that's negative 30. So then as far as combining, I just need to combine like terms. I've got negative 28 and negative 30. That's a negative 58. And then I've got 14 square roots of 3 plus 20 square roots of 3. That is 34 square roots of 3. And there we go. Okay. On number 22. So we're back to dividing. For 22, I need to simplify numerator and denominator and then see about rationalizing. It is a square root, which makes these a whole lot easier. Has anyone already done number 23? I'd like to make it a cubed root just to make it more practice for the other one, but I might work it out both ways. Okay. Okay. There's nothing I can simplify with the coefficients because that's a 1 and that's a 6. I can cancel out one of these x's with one of those, leave me with 2. And 4 of those with 4 of those, leave me with 1. So I am left with the square root of x squared over the square root of 6y. The square root of x squared in the numerator is just x. 2 goes into 2 one time over the square root of 6y. So I need to rationalize, which means multiply, by the square root in the denominator. Since it's a 2, I only need 2 of them to cancel it out. So my numerator is x square roots of 6y over just 6y. Because this is an understood 2, I only need 2 of them to cancel them out. And there you go. And I don't have time to do the next one before the bell rings, so I'm going to put that, or this first video right here.